Okay, guys, welcome to the short lesson today, and this one should be pretty quick. It's an intro into something that is a little bit unusual, and it's actually kind of an out-of-the-book chapter, so we won't really find this in the book, but it fits really well with systems of equations, which we just learned about, solving systems with two variables. Now, one of the things we did skip in the book for the time being was solving systems with three variables, right? So instead of just an x and a y, we had an x, y, and z. The reason we skip those for the moment is because they're fairly complicated to do. They take a lot of substitution, a lot of elimination, keeping track of everything. And anymore, we've come up with better ways to solve them than by hand. And so we're going to address that and talk about how to do it. So first off, I've got a title up here for section 6.3. I'm actually probably going to title this chapter 12. And so I'm just going to call this like the 12 intro. All right, this isn't necessarily a section per se, but kind of an introduction into what I'm going to dub as chapter 12. So yeah, we're skipping way ahead for a moment, but that's because it fits in really well. And we're going to talk about these things called the matrix, not like the movie, but a rectangular array of numbers. And that's exactly what a matrix is. It's a rectangular array of numbers. And so you can see an example here off to the right. I'll kind of circle it. This is matrix A. So, A equals is what it's saying. It's matrix A. And this one has has six numbers in it. And we'll identify them by the rows and columns that are in there. And each number that's in that is called an element. All right. And you can identify each element by its row and column number. So we also name sometimes matrices by row and columns. So for example, like matrix A here has 2 rows, all right, and 3 columns. The easiest way to remember which one's rows and which ones are columns is like to think about columns on the front of a building, right, that run up and down. So columns in a matrix also sort of run up and down like the columns in a building would. All right, let me erase that. All right, so this one would be a 2-row by 3-column matrix, so we would call this a 2 by 3 matrix, right here, 2 by 3 matrix, read as 2 by 3. And so then what we can do is we can refer to any of these given numbers in this particular matrix with like a little coding system. So in matrix A, for example, if I gave you the notation and I said, hey, what is A sub 2, 3? Sub meaning like, kind of like a off to the bottom right there. So A sub 2, 3. And what that's asking is for the number, the element that is in row 2, column 3. We always go rows and then columns. So we look and we say, okay, what is A2, 3? So we go to row 2, which will be this row right here. And then we look in column 3, which would be this column right here. And sure enough, that intersection point is, in fact, 3. So we would say that element is 3. So A sub 2, 3 is 3. Now, that's a little bit about how matrices are set up and how to identify things in them. Let's talk about what they can be used for. So since we just got out of chapter 1, which at the end was all about solving systems, we can actually organize systems into a matrix. Matrices are really useful when it comes to organizing a lot of information. And so, for example, what we can do is we can take this system, 2x plus y equals 8, x plus 3y equals 11, and take the coefficients of the variables, meaning the numbers out front of the variables, and put them into a matrix. Now, one of the things we need to do, it was hard to do in Microsoft Word, was to sort of complete that bar. So I'm going to go ahead and kind of attach that bar each side of it. And we get this nice matrix where 2, 1, 8, 1, 3, 11. Okay, now that bar essentially represents an equal sign. Let me change my color there. Right, so that's kind of essentially what we're doing is we're setting this up. The bar is optional if you want to have it there or not. It's completely up to you. But it does represent, well, we can say over here, the equals sign. All right, so let's jump into kind of setting some of these up. So we'll start with a system here. All right, so we'll create our matrix. And essentially we're going to use this, right, like we said, to, in the next couple steps, in the next couple problems here, to solve these systems. Now we used to solve these systems by substitution or elimination, maybe even graphing if we had a graph available. But we'll look at these matrices. So What we're going to do is we're going to take the coefficients. Obviously in front of the x there is a 1, and then -4, and then 10, and of course -2. There's a 1 in front of that y, so a 1, and then 14. And again, you can choose to put the bar there or not. You'll see me do it on some examples, and then on others I won't. All right, so let's look at something we haven't done before, a system of 3 equations. When we have a system, or of 3 variables, I should say, when we have a system with 3 variables, we need to add a third equation in here because technically we should have 3 equations. So we'll go ahead and just add one. I'll fix my bracket over here. So I just made that one up just to get a third one in there. And let's go ahead and create that matrix. So we'll look at the numbers out front. Looks like there's a 2, a 3, a -1, a 2, a -1, a 3, 2, -4. And then our last equation has a 2, 5, and then there's a 1 in front of that z, and then a 5. All right, we can put the bar there to kind of separate them. So yeah, we, in the last chapter, chapter 1, the one that we're kind of testing on right now, didn't actually get to solving systems with 3 variables. They're pretty complicated. They are very error prone, or prone to making mistakes in them very easily. And so we saved them kind of for this section to show you how to solve them without having to solve them by hand. However, we're also going to look at 2 variable systems. We did solve those by hand. So one's like this, right? But again, we'll kind of talk about how we can use the calculator to solve that. All right, so let's do this. Let's talk about solving that. And what I'd like to do is I'd like to solve this system right here. The one to the left of it, but the matrix for the system that we made. And so we're going to use our calculator, and I'm going to tell you kind of how to do that. So the first thing you're going to do in your calculator to deal with matrices is to go to second, and then you'll see there's the alpha key right below the second key, the math key below that, and then you have this x to the -1 key. And if you look right above the x to the -1 key, it says the word matrix. So hit the second x to the -1 key. So let's jot this down, second, and x to the -1 key, and it should take you right to that matrix menu. Now you should see a big list of matrices, A, B, C, D, E, F, G, and if you're borrowing a calculator or using maybe a sibling's calculator, someone else's calculator, you might see some numbers next to those A, B, C, Ds, like a 3 by 3 or a 2 by 2 or a 3 by 4, or maybe you don't see any at all. Well, what we need to do is we need to enter our matrix that we want to solve, the one I have circled here on our notes. So to do that, we're going to scroll over in the matrix menu to the edit function. All right? Edit is where you're going to be able to enter matrices in this chapter. So let's just edit matrix A, and you can scroll up and down the matrices. You can go to A, B, C, D, and E, F, G. But I'm going to choose and hit enter on matrix A, and it'll take you to a new menu. Now the first thing it'll ask you in this menu is kind of to determine the size of the matrix. Like right now, it might say like a 1 by 1. Let's go back up here real quick. Remember that we do rows and then columns. So this is a 1, 2, 3 row by 1, 2, 3, 4 column. All right, so we've got a 3 by 4 matrix. So I'm going to go ahead and enter 3, enter 4 up at the top, and it should adjust the size of that matrix. And you can kind of scroll left and right to see all of the elements in there. Now right now there shouldn't really be anything, so we need to manually enter the numbers. So I'm going to enter 2 in my first spot, and then it'll jump to the right where I'm going to put a 3, and then a -1, and then a 2, and then a -1, 3, 2, -4, and then our last one will be a 2, 5, 1, and 5. All right, so we've entered that in there. Let's fill out our notes here. So we scrolled over to edit. We chose matrix A. We entered our numbers. Okay. Now, anything you do from this point will keep editing the matrix. So we actually want to quit out of this menu. So we kind of finalize our edits. So to do that, there's the word quit right above the mode key. The mode key is right next to the second key. All right, you'll see the word quit there. So go ahead and hit second mode, and it should, all right, second mode, and I'll often refer to that as just second quit. That'll get you back to the main menu. So now you should be back on the main menu, and now we want to solve this particular matrix. So to do that, we need to go back into the matrix, so second x to the negative 1 power, and now under names, you should see matrix A list that there's a 3 by 4 matrix entered into that spot. All right, if you don't see a 3 by 4, go back over to edit and try entering your matrix in again. But okay, so here's what we want to do. We're going to do this thing called row reduced echelon form, REF is what it's called. And REF is essentially kind of a roundabout way to solving systems of equations by doing different operations on the rows and columns and then adding them together, subtracting them, multiplying them, kind of like a big elimination problem. But just like solving a matrix, there's a lot of steps to row reducing, and it's easy to make a mistake on, plus we can rely on technology to do it for us. So we're going to have our calculator row reduce, and I'm going to rewrite this, the following matrix, the one that we just entered in from above. All right, so to row reduce, once you're in the matrix menu, which we should be now, scroll over to math, okay? And in the math menu, this is all of the stuff that we can do with matrices, and we haven't talked about any of this yet, so it's all very new. But we are looking for ref, and it's way down on the list. So instead of scrolling down, I actually suggest people, when they're on the first option, to scroll up. If you scroll up, it'll take you to the bottom of the list, and you'll see ref. For me, it's option B. Don't choose ref, okay? The reduced echelon form, we want to do ref, row reduced echelon form. So go ahead and hit enter on the RREF. Should take you back to the home screen where it now says ref parenthesis, and then it should be blinking with nothing there. Now obviously we want to row reduce that matrix, so what we need to do is we need to plug matrix A into that spot. So without doing anything else, we'll go back to second matrix one more time, and instead of going to edit to enter a matrix, since we've already entered a matrix, we will just hit enter on the names category on matrix A. So just go ahead and pretty much hit second matrix and then hit enter is essentially the step. And it should take you back to the home screen. You should see ref with the matrix A entered in. Now you can close off that parenthesis if you want, but it's not necessary because we're not going to do anything else. We're just going to hit enter. All right, so here's what we get. Here's what you should get. 1, 0, 0, 0, 1, 0, 0, 0, 1, and then over here 5.25, negative 1.75, and 3.25. All right, so again, let's fill these directions out. Once you exit, you go back into second and then matrix. You scroll over to the math menu. You choose ref. Then you go back into second matrix and choose matrix A and hit enter. All right, those are your steps. So if you're having trouble, try to go through these steps one more time. If you're still having trouble, obviously we can talk about it in class or sit down one-on-one and kind of make sure that you've got these steps down. And of course, on Tuesday when we all come back together, oops, where am I at? There we go. We will practice a bunch of these in class too, so we'll kind of get it down. All right, so what does this mean though? And this is our last thing we'll talk about here. This looks really complicated and doesn't seem to mean much. You see this diagonal of ones sort of going down the middle here, and then you obviously have your numbers out on the outside and everything else is 0. Well, let's talk about those ones for a second. If you guys recognize, every single equation on the original system that we're solving goes x, y, z, x, y, z, x, y, z. So, in other words, same thing over here. It sort of just goes x, y, z. Right? It follows that same format. So if you look at this part of the equation real quick, apparently x, it's 1x plus 0y plus 0z. In other words, there is no y and there is no z in that equation. There's zeros in that spot. So the only variable that's there is the x variable. So this entire line right here, the whole thing, now including the 5.25, reads x equals 5.25. Okay. Same thing down here. This line, the second one, you'll notice that it goes 0, 1, 0. Well, if you look up at the top again, that's a 0 for the x, a 0 for the z, but there is a 1 for the y. So that actually means that there's a y in that part, and y equals negative 1.75. And then, of course, the last and final one, the last row here, 0 for the x, 0 for the y, a 1 for the z, so that means z equals, and z equals 3.25. So as a coordinate, 5.25, comma, negative 1.75, comma, 3.25. And of course, this coordinate is 3 parts because a variable of 3, or a system of 3 variables is actually in the 3 dimensions. It's got an x-axis, a y-axis, and a z-axis that kind of runs like forward to backwards, okay? So instead of left and right, up and down, you've got one that actually goes backwards and forwards. So there's our coordinate where all 3 of these lines intersect, and that's how we'll solve systems kind of from now on, including ones like 2 variable systems that we've been using elimination and substitution on. All right, so when we come back on Tuesday, what we'll do is we'll follow up and we'll just kind of recap on a few of these, and then we'll go from there. Thanks.